Okay. Today we're talking about IP subnetting. So let's see how we can give examples. Okay. So we can start the example with the class C address. That's easy for learning. Let's say 192.168.10.0/24. This is class C classful. Class C classful. Classful, or we can call it as a default network. And there's another one which is called classless. In classless, we have a two subject. One is called subnetting. The other one called supernetting. Supernetting. Okay. So let's say when you have 192.168.10 dot network, the last two octet in class C are defined for your host or your computers or end devices. So this is 2 raised to 8, which means 254 valid number. So by having 192.168.10.0 network, you can use maximum 254 computer with a single network. Okay. Let's say in this network, if you have only 10 or 20 devices, the rest of the IP within the subnets are unused. And if you need another network for another services, you have to take a different network altogether because this is completely one network. So what is the benefit of doing subnetting? It will generate multiple network based on your requirements or your customer requirements. I have uh, 3 division. Each division I have, let's say 30 computer, 60 computer, 25 computer, something like this. So when all together the number counted, a number is less than 254, which means by having your single network, 192.168.10 network with a 254 IP, you can even divide it into 3 different categories. So we will going to learn how we can do this. So let's say the by default /24 is the default network bits for class C, which means your 24 bits are on. 8, 8, 8. Then you have 8 bits is off. So 8 plus 8 plus 8, 24. So 24 on and 8 are off. This is the default in class C. So what is subnetting? We have to understand two things. What is subnetting and why do we need to do subnetting? So let's say, what is subnetting? Adding or borrowing off bit. Off bit in the sense which are zeros. So purchasing off a bit into on bit. Hope you understand. Adding off value to on values. Example, the 192.168.10.0 is the class C, which means 192.168.10.0 24. You will have 1, 2, 3 till 254 and 255. These are your available address in class C with a single network. Okay. If a customer says that, or when we do design, we came to know that we have a 2 different network. Example, one for let's say data, for connecting computers, then one for voice, IP telephony. So I need a two different network. By having 192.168.10.0.24, either I can use it for data or even I can use it for voice. So either of the case, I need to have another network. Example 192.168, let's say 11.0, another network with a 24. Again, I have a 254 valid IP. But looking into this, I have only, let's say, 50 data points, 50 telephone points. So altogether, I have only 100 points. But keeping in separation with the default, I'm unused IPs are more than 100 or 150. So adding additional bits or procuring bits from the host portion to the network portion, as I said, called subnetting, and doing subnetting to get multiple network within the major network. So let me explain again. Let's say this is 24 as a default. I'm going to use 2 bits. 2 bits. So when it's say, let's say, can you go for 1 bits is an easy 1 bits. So when I say 1 bits, the 24, let's say this one, already I have a 24 here. From the 8 off bit, I'm going to use 1 bit. Okay, so total how many bits on? Slash 25. And 7 bits are off. So when you adding extra bits from the default, which is a 0 to 1, adding off bit to 1 is called subnetting. So when we have 25 slash, which is adding one extra bit into the default, let's see what are the changes will occur. So the first task, you will write individually. Okay. Then we will identify the number of network. How many network that's we gonna get? Okay. So for that, what we can do, let's say the default is 192.168.10.0/24. We're going to do a 25. Okay. The number of on bit or number of network, or we can say number of extra on bit. Any idea how many bits we turned on extra? 1, just the 1, which means 2 raised to 1. So 2 raised to 1 equal to 2. So number of extra bits on, which is 1 bit. So we will calculate with the 2 raised to 1. The outcome is our number of network. So the first task is identify the number of network. Earlier, when you had 192.168.10.0/24, you had only one network, 192.168.10.0, and you had 254 IP within that. When we adding 1 bit from host to network, which is called subnetting, the slash value is being changed from 24 to 25. Then our first task to identify the number of network. To identify the number of network, we're gonna use number of extra on bits, which is 1. So 2 raised to 1 is equal to 2. You're gonna get the 2 network. Hope you understand. Now we need to know what are those 2 network. Earlier, this is a single network. Now we have a 2 network. So to identify the two different network, the easiest way, two five six minus decimal value of extra bit on. Okay, so which is the extra bit on? Let's we start from 2 raised to 0 from here, and this is 2 raised to 7.
Wha-
Two, yep.
128.
So 128. So the extra bit value 256 minus 128 equal to 128. So we need to add 128 on the changed octet. So here the changed octet is the last octet. So we will try how we can. Okay. Yep.
One doubt. We are going to at 256 or 255 minus
256.
120.
256.
25.
The total
Okay.
number is called 256 from 0 to 255.
Okay. Okay.
Okay. Now 192, 168, 10 dot. Always it start from 0. Okay. In any subnetting slash, what is the value? 25. Then we said add with the 128 to get the another network, which means 190 to 168, 10 dot, 128, 25. Let's you try adding with the 128. What will happen? Because we said to add 128. So from the first network always start with 0. Then we added 128 to get the another network, which is 190 to 160, 10.128, next network. Then we try adding 128. So let's see what's going to happen. 192, 168. 128 plus 128 equal to 256. So here we will have only maximum 255. There is no 256. So what we're gonna do, the additional one, which is 256, this one we will be adding back, because you cannot add on the last octet. It is already completed 255. So when you're adding one to the back octet, so the 10 will become 11. This is entirely different network. So you cannot do that. This is the one way to identify, or one of the easiest way, you got the second network, and we already informed that the number of network availability is maximum 2. Yeah, so you already have 1 and 2, so then you can stop it. So this is the way that you identify the number of network. So any computer comes under this value shouldn't communicate with the above value unless we do routing each other. So let's say we found 2 network. This is the second task. Now the third task, how we can write IPs within the network. So as I said in the very earlier, when it completely off, which is 0, called network, right? Then when it completely on, this is called broadcast. So we'll start with 192, 168, 10.0, 24. This is your network because this octet is 0. Okay. Now network plus 1, your first IP, which is your network 0. So 192, 168, 10.1, your first IP. And you can write your next network. What's your next network? 10.128. This is your next network. So okay. So this is your second network, next network. Now, network -1, that is your broadcast. So 192.168.10.127. This is your broadcast. Now, broadcast -1, last IP. So 126 is your last IP. So whenever you have any network, your valid IP must be lesser than 2 than that network. Why do we need lesser than 2? One for network, one for broadcast. So let's say this is your second network, 128. So the network plus 1 is your first IP. So 129 is your first IP. Okay. Then either you can count till 126 IP, or as you know, the last value would be 255. That's your broadcast. So 254 is your last IP. So which means I'll keep this here. Then let's say you have one switch. Let's say these are one network and these are your second network. So this IP you can give 192.168.10.1, and this is 192.168.10.2 dot, this is 25, this is 25. Okay, 10.1 and 10.2. And this network, which is your second network, you can define 192, it's not clear, 192, 168, same 10 dot, let's say 130. 130 become under 128, your second network, slash 25. What if you mention slash 24 here and here slash 24? This will become same network. You cannot split it. That's why we do subnetting. So this is, let's say, 131.25. Okay. So this will become under one network, and this will become under another network. Okay. Hope you understand. Can we give for another example? We have taken 1 bit now. 1 bit. Okay. We'll go for second bit. 2 bits. So you'll get a little more idea. We'll continue. Now you need to tell something in this. Let's say I'm going to take 2 bits. Okay. 2 bits in any address that you can give. Let's example, I'm going to give 200, which is class C. 200, 10 dot, 100 dot, 0. 200. When you start 200 in between 190 to 160, it belongs to class C. So this is 24. Okay. No need to give always 190 to 160. Any class C address as a beginner to learn the subnetting. Now, what I've mentioned, 2-bit subnetting. So the first task, write PL. What is PL? This is prefix length. Okay. So 200, 200, 10, 100 dot 0. default 24. We're writing about 2 more bits. So slash, how much it comes? 26. So 24 plus 2, 26. Clear? First. What is first? Number of network. How you can identify the number of network? To identify the decimal value, to identify the number of on bit. How many bits is extra on? 2. So which means 2 raised to 2. How much it is? Which means 2 into 2, 4. So the number of extra bit on is 2. So the number of network is 4. 2 into 2. So you have 4 different networks from a single classful network. A single classful is this class C classful network. From this, we're going to generate 4 different network. When you're adding extra bits, adding additional value higher than slash 24, which is 26, we call it as a subnetting. Borrowing bits from host to portion to network portions. So the second one, what is second one? Number of host, computers or edge device to connect. Number of host. Okay. So number of host, we can identify 2 raised to, we can put y value. Why 2 raised to y? The y is equivalent to half a bit of bits. So let me know how many bits are off. How do you calculate the off bits? This is 26. Okay. What is the total number of IP? 32. Total. How many on? 26. So how many off? The rest, the remaining.
6.
So 2 raised, the y is off bits, which is 6. So 2 raised to y is equivalent to 2 raised to 6. So 2 raised to 6 in the sense 2 into 6 times. How much it comes? Correct?
2 is to 5, right? 6. So 2 to the 4, so
Okay, so we'll calculate. 10, 2 raised to 6, right? 2 into 2 into 2 into 6 times. How much it comes?
64, right?
Right now. 2 to the power of 6. So total is 64. Any doubt? If like, we can make it here as 2 raised to number of networks, we can put 2 raised to n. The n is equal to on bit. Like we said, y is equal to off bit, n is equal to on bits. How many bits is on? 2. That's why we got 2 into 2, 4s are. 2 into 2, 4. There are many way, but we wanted to make sure that we all
It is
agree. Yeah,
it is calculating from the left to right on bits. Yeah, left to right, correct, right?
like this,
Yes.
like Arabic. Okay.
Yes, yes. The on
So
bit is the from the left.
yeah, so this 24 adding to 25, 26, which is 2 bits, 2 raised to 2. The remaining, you can count 27 off to until 32. You get 6 values. Or the total IP 32, the total on bit is 26. So minus, you're going to get 6. It's not 7, huh? Just put the arrow mark. 6. So 2 raised to 6 is equal to 64. 6 times of 2. 2 into 2 into 2 into something until 6 value called 64. Then always when you get number of hosts, either subnetting or in class full, default, you need to minus 2. So how much is remaining? 62. Why do we want it to minus this? So this minus value 1 for your first, which is called network. The one is called your last, which is called broadcast. Now you came to know that you have a 4 different networks, and each networks will have 64 value and 62 are a valid host address. Okay. Now we wanted to write those address. How we can write? So for that, the third step says 256 minus the additional value that you got. How much you got? 2 raised to the additional 2 bits on,
120, 128 plus 64.
which is 192.
One,
So how do we
two,
came to know this value? So let's say your on bit 8, 8, 8. This is default. Okay. Now 0, 0, 0, 0, 0, 0, 0, 0. This is the default. How much it is? 24. Correct. You added 2 more bits. When you added 2 more bits, which are those bits? This one and this one. So 24 plus 25 and 26. That's what we mentioned, 26. So to come to know how to write to get the complete IP schema, you can do with the 256 minus decimal value of extra bits on. Which are those 2 extra bits on? 2 raised to 7 and 2 raised to 6. 5, 4, 3, 2, something it's go like this way. So 2 raised to 6 is 64. 2 raised to 7, 128. So adding 192. Okay, this is the uh, 192 total value. Any doubt?
once again, so 192 is the network.
No, no, no. 192 is the decimal value of your extra bit on.
Yeah,
Okay. Now I written how you got the 192 value.
yeah, that's fine. 192 host is not available.
No, I
0
didn't.
bits on.
I didn't tell anything
Oh,
about the host. I just wanted to come you to know, or all you guys need to know that our what is our next task? Okay. Number of net. Identify the number of network. You clear? Just to check the additional bit value. How many turned on? 2. So 2 raised to 2 equal to 4. So you get the 4 network. Clear? Second, number of host. To identify the number of host, you need to identify the number of off bits, which is 6 here. So 2 raised to 6, which is 64. Clear? So now you have 64 number in each network and you have a 4 network. How will you write those network? That is the next task. How we can identify 256 minus 192 or 256 minus the decimal value of your extra bit on. So the extra bit turned on are 2, 25 and 26. So when you had 2 bits on, 192 is the value. So 256 minus 192, how much? 64, right? Yeah. So now we can add with the 64. So how you can write the IP schema? Okay, what's the number? 200, 10, 100, 0/26. First, always the first network starts with the 0. Okay. Then your changes with the 64 to be added on the last octet, which means the changes occurred on last octet. This is 26. Okay, so 24, 25, 26, the last octet you need to add. So let's say 200, 10, 100, 64. What is next value? Adding with the 64. 100 dot 128. 100 dot 192. What if I'm gonna add 64? What will happen? 192 plus 64 is 256. You cannot add, so it's gonna be 101. So it's a different network. Or in other way, you can see here you have 1, 2, 3, 4. How many network you're gonna get? 4. It's matched. Any doubt? It's very important in real world to do practical real device configurations. Any doubt? So the steps are very easy. First, first slash value, prefix length. Second, number of network. Third, number of host. Fourth, what is fourth? How to add, which is 256 minus extra bit on value. That's it. Then you have subnet mask to define. Okay, we'll take one more example so we can together can clear it out. So here we had /26. /26 in the sense two more extra bit on, which is 192. So the subnet mask would be 255, 255, 255, 192, when extra bit on. Okay, thank you.